Today we're going to talk about triangles. So the first thing we need to do is define what a triangle is. It is a polygon with 3 sides and 3 angles. There's 2 different types of angles for a triangle. There's interior, which is inside the triangle, so that would be these. And then there's exterior, which is outside the triangle. So that would look like this. This one, and this one. And lastly, we need to define the corollary of a theorem. A corollary is an additional part of a theorem. There are 3 ways to name a triangle by its angles, or by its sides. The first one is scalene. A scalene triangle has 0 congruent sides. Isosceles has at least 2 congruent sides. We know that these are the congruent sides of the triangles because of these tick marks. And then an equilateral triangle has 3 congruent sides. Again, there are 3 tick marks, 1 on each side. You can also identify a triangle by its angles. An acute triangle will have 3 acute angles. A right triangle only has 1 right angle, and an obtuse triangle only has 1 obtuse angle. Lastly, this looks very similar to equilateral. It's also called an equiangular triangle, which just means you have 3 equal angles. Alright, so the first thing we're going to do is classify this triangle by its sides and then determine if it is a right triangle. So first let's classify it by its sides. It is on the coordinate plane, so I should use the distance formula to find the length of each side. So first let's find the length of R to T. The distance I'm going to subtract. Square them, add them, and take the square root. We have 2 more sides that we have to find. So let's go ahead and do those. We have RS. So far 2 different size sides. So by its sides, we can classify this as scalene because none of these measures are the same. Now you also need to figure out if this is actually a right triangle. If it is a right triangle, that means that the slopes of the lines would be perpendicular to each other and opposite reciprocals. So let's go ahead and test out the ones that actually look like they could be perpendicular, which would be this from S to T. And from R to T. Since these are opposite reciprocals, they are perpendicular, so this would be a right scalene triangle. Our first theorem about triangles says that the three angles in a triangle must add up together to give you a sum of 180. So for example, if this was 60 and this was 40, this is already 100. And so you need 80 more in this angle right here to make 180. So the sum of the measures of the interior angles of a triangle is always 180 degrees. Here's a visual proof of why this works. Dramatic. So that's triangle ABC. A straight line is also equal to 180 degrees. A is placed on the line. B is placed adjacent to A. And lastly, C is placed adjacent to B. Notice they all fit perfectly on that straight line, totaling 180 degrees. Brain power. All right. Secondly, there's another theorem that says if you have two interior angles of a triangle, so let's say I had this being 60 and this being 80, I could easily find the missing angle inside the triangle because 60 and 80 is 140 and 180 minus 140 is 40. So that means that this angle right here that I just did in blue would be 40. So now what if I asked you to get the angle that's supplementary to 40? You would just take 180 minus 40. But look, we've already gotten 140 up here. 140 came from these two angles over here. So let's test this out again. Let's say this is 60. This is 40. Okay, well 60 plus 40 is 100. That means the interior angle is 80, which means the exterior angle is 100, but I already got 100 from these two angles right here. So this theorem is the exterior angle theorem. So in this picture, the measure of angle 1 would be equal to the measure of angle A plus the measure of angle B. Generally speaking, for any triangle, it doesn't have to be called ABC. You would just say that the measure of the exterior angle is equal to the sum of the measures of the two interior angles. Algebraically, here's how you would solve this problem. You have the two interior angles. These two add up together to give you the exterior angle. Go ahead and move this x over. Add 9 to both sides. So x equals 42. Here's another one. These two interior angles equal the exterior angle. Move x over. Subtract 16 from 52. Oops. And lastly, we're going to use this word corollary. So the triangle sum theorem says that the interior angles of a triangle have to equal 180. In addition to that would be that if you have a right triangle, you're already taking 90 away, which means the other two remaining angles have to additionally equal 90 degrees. You could say the acute angles of a right triangle, since they equal 90 degrees, are complementary to each other. What? So if I have this right triangle and I said that this is 10, you don't have to do 180 minus, this would be 90, plus 10. That's 100. Equals 80. You could just do the other 90 degrees of the triangle because you already have 90 here. You could do the other 90 degrees minus the angle you're already given and just get 80 that way. So here's an example. It says the front face of a wheelchair ramp shown forms a right triangle. The measure of one acute angle, so that would be this one, is 8 times the measure of the other. So that's this one. This is 90 degrees, but technically I do not need to use this. So let's make this one the larger of the acute angles. This is 8 times the other angle, which I don't know the size of as well. So together, 8x plus x equals 90 degrees. You already have 90 here. You don't need to use the other 90. So x equals 10. And now the measure of each acute angle would be 10 degrees and 80 degrees. After you're done watching this video, you're going to go to Go Formative and you're going to do the worksheet that says Triangle Sum Theorem.